Oh, I guess I'm ready. Not really. I think I'm connected to the internet. Let's see how this works out. Oh, serverless. How many people know what serverless is? Good, because I don't. But I'm going to give this talk anyway. And I'm coming from the world of servers and containers, roll your own. All those things are supernatural to me. So being introduced to this world called serverless, and OK, the name is pretty bad, but it does describe something super important. So I'm coming from this world as not an expert, but as someone transitioning to this new way of thinking about compute. Okay? So the goal of this talk today is to really put serverless in the context of somewhat the Go developer, but maybe people coming from a similar base into this new world. Now, when I think about serverless, some things that are very core to it, because the name is getting diluted quite a bit. Everyone is using serverless to describe just about everything these days. So it's becoming meaningless, right? Serverless means everything and nothing at the same time. So we're going to put a little context today to it. So the first thing you got to do is talk about functions. Now, this is the first place where I see people go astray. They believe that this serverless thing is all about writing these little functions and having them do things. And some people would say this is just CGI. Anybody remember CGI scripts? Some of you are probably still running them in production. It's OK. Got to make money somehow. I remember a world where, and people say, why are we using these function things? What benefits do serverless have? And the idea is that there are so many patterns around how to invoke a process and have it handle something that we can probably move that into the provider. It feels like that is the dumbest idea ever. I can't give up control into this black box. And I hear this from Go programmers who allow the Go runtime to manage memory and threads and everything else. You've already yielded a lot of control in your programming language of choice. And then about 20 years ago, there was this thing. And I actually asked someone at the after party if they knew what this was, and they didn't. And I was like, damn, I'm getting old. So I'm going to show you this thing, and some of you may remember what it is. Let's see. So when I thought about functions for the first time, this is what came to mind when I saw this stuff in action. Tmux for the win. Tmux A. We're back. So there's this little tool called XNID. Make noise if you know what that is. Half of you are lying your ass off on Wikipedia right now, like XNID. This is the new hotness. So the nice thing is, back then, before we had some of these more convenient languages, it was really, really hard to write a daemon. Right now, in 3 lines of code, you can just write a service, and it's like nothing to think about. But if you're trying to do this in maybe a lower-level language, it was pretty significant to actually write a daemon that worked, right? Especially if you then close out all your file descriptors, you can actually run into some serious problems. So we had this little tool called XNID that will let you do something like this. XNID is a super daemon, and it will do all the listening for incoming connections. And you can do a config like this and say, hey, XNID, I want you to listen on port 80. And I have this service called Hello World. And if you're really old school, you know about this business. Let's see. Who knows about that one? Yeah, you just pick a port. Ignore everything at the top. It's like, port 8080 is mine. If you're legit, you may grep through there, but who cares? It's my server. 8080 belongs to me. And you throw this config in place, and then what it will do is invoke this binary and do all the heavy lifting of dealing with the daemon for you. And back then, a lot of the servers were memory constrained, so you just didn't want to leave all of your services running, wasting resources. All right, so what does the service look like? I'm going to show you a very simple one. So here's a Hello World, little simple app. And I don't need to worry about any of the TCP stuff. I know I'm just going to get a stream of bytes coming on standard in. And my job is to process those and send it back. That's it. I don't have to worry about handling multiple connections. XNID does it for me. So given this config, what we should be able to do is just run something like incat to invoke this particular function. So let's try it. Oh. All right, let's see. NC 127.0.0 8080. And it works. If you're a new Unix admin, you take you a year to get out of this console. It's like Control-C. And I can do this as many times as I want, and that super daemon will handle the life cycle for me on this constrained system. So when I think about serverless and functions, we do this, but on a much bigger machine, and we just think of that as the cloud. Much more efficient way of thinking about computing. And then we move a lot of the boilerplate of what it means to handle a connection to the provider itself. So this is a good frame of reference to start thinking about this particular problem. I have a few more slides, and then we're going to try to see what some of this stuff looks like in action. So what's serverless? So there's functions, and this is where you have just the smallest bit of programming logic, which isn't always true, to perform a specific task. Now, I'm watching people write monolithic functions. I'm not sure why people are doing that, but there are some trade-offs that you make by only being able to do one thing per function. And the next thing is events. You don't have a daemon that you control, so you can't pull a message queue. You can't pull an HTTP server. You have to have something else, just like XNID, invoke your function. And the most important piece that I've come to realize is managed services. If you are installing your function framework first, you might not be doing things in a serverless fashion. How many people use a bunch of serverless services today? Not a lot of hands. How many people are using a hosted email service? All right, so the rest of you are obviously confused. My guess is you probably use way more managed services than you believe. And this culture started a long time ago. It's just now accelerating because of what services are available, okay? And the whole goal is that you focus on business value. Now, some people do not care about this part. They just write their own. Oh, the Golang crypto library is too slow. I'm going to write my own. And then it all goes downhill, okay? So the goal is these standard libraries, like managed services, are there so that you don't have to reinvent the wheel, and then you get to just focus on, hopefully, business value. And this is one that's hard to swallow, because some people believe they should just write everything themselves. Some of the use cases. Now, this is the first one that really threw me for a loop. In the serverless world, you get one function per thing. That means one function per resource. So if I want to delete a user, that's a function. You want to create a user, well, that's another function. And for your whole service, you're going to have one function per resource per path. And then you push all your other functionality to an API gateway to do everything else. Very similar to what we do with something like Nginx and your microservices. But in this case, it's, to me, a bit extreme to break every single thing out to a single function. You may end up with 10,000 functions. No one's really figured out how to manage that, but it's cool. It's new. The other one is this whole data pipelines thing, okay? Some event occurs, you process the data, and then you move on. So these are kind of the two cases that are presented to people. So I'm out of slides, and we're going to do the rest of this with like live working code, okay? So big shout out to Amazon. They were the first provider to provide Go support in a serverless fashion. And working at Google is kind of shameful watching this happen. You're like, damn, that's like our language, man. We got it done. And this is really irresponsible of me of showing our alpha support for Go natively, no shelling out to Node.js. So what we used to do is used to shell out from Node.js to invoke Go binaries to feel good about ourselves. Didn't work out so well. So now we have this thing. So here's the trick. When most people show you serverless stuff, they always start with the happy stuff, right? It's like, oh, serverless is the best thing ever, right? And they always start with like this hello world thing. They're like, let me show you. And then for some reason, they feel that we're going to ditch our IDEs and code applications in some console. That's not going to happen, actually. So here's the source, right? You're like, oh, look at that. There's no main, no setup. That's a working application. And if I wanted to, I can hit this with a trigger URL, All right, demo gods, you're on my side, please. So we come here, and we get the app from just that little snippet of code. So you're like, yeah, I'm going to rewrite all the company's apps in serverless. This is what you do. This is the only proof you need. So the next thing is like, well, how do I test this? So you're like, OK, yeah, I mean, why are you asking all these hard questions, man? The nice thing, though, about Go is the fact that we can easily test this handler just like any other handler, right? It's just a function. You can use the HTTP test package here. And what you can do then is just call once you set up your HTTP server that's running, you set up a little recorder, and then you can just invoke this handler like you would normally test anything else. So if you know what the event that's coming in, you can just unmarshal it and do what you were doing. So testing is somewhat similar. So now it's like, what does it take to be production ready? Okay? Now, any new developers here, raise your hand. Do not be shy, because everyone's been new at some point. I'm going to show you the ultimate trick. This is what all the senior engineers do. So if you want to know how to make something production ready and you're new, this is the place you go. If you're a senior engineer and you don't know about Stack Overflow, I have questions. So you come here and you just do basic stuff, OK? Like this, Google, Cloud, Functions, production, OK? And remember, this is the internet, so you can trust whatever you find. And look at this. Like, what does a quality production server function look like? All right, they're all hello worlds. That's the extra pro tip. Ask questions, OK? Because you might get answers. So here's the thing. All right, you got to be responsible. So you scroll down, and usually the first answer you see is probably the best one. OK? Trial and error is OK. OK? So you look at this, it's like, given the provider takes care of things like scaling, you should probably focus on observability, right? These serverless platforms tend to be like black boxes. You need to think about tracing data and logging so you can have a view into what's going on. So I look at this, and I was like, OK, it's a bit of code. I mean, he has a comment in here. This is legit. OK. OK. You ever do that, like Google, and you find it, you answer your own question? It's like, shit. I knew this all along. So, and there's some steps here. So the other thing you want to think about too is this. There's this thing, as they say, good developers copy. All right, so you come down. All right, let's get this one. But let's do this. So go to this hello world code, OK? All right, so the saying is, good developers copy. And this is the other pro tip right here. Watch this. You guys are going to be in for one. Great developers paste. All right, so this code is probably legit, but you shouldn't just put it in production, OK? I would recommend you read the code, but yeah, time is limited. So the nice thing about this whole serverless thing, since you only have a handler, it will be nice if I can code these things anywhere. GoPath really doesn't work that great in this kind of scenario. So I'm using Go modules here, and I just kind of have this very simple thing. Now, unfortunately, there's a lot more code here than when I started, so you might want to do something like this. Go mod vendor. I mean, you probably want to bundle your dependencies so this stuff can be repeatable. So let's see what the dependency tree looks like, OK? And again, this stuff is coming from the internet, so it's probably safe and legit. AWS. You need what you need. OK, so you have this vendor directory. You have all these checksums. And the only thing left to do really is, the most responsible thing to do at this point is probably to just deploy it. Just if there's any security vulnerabilities, it's their platform, not mine. So we'll just do that. So we'll let this run, and then we'll test it, OK? So this is what these things actually start to look like when you start to really think about production use cases. But we need to do something more than hello world to get through this. So what I want to do is I'm going to build a weather application. And this is a weather application that I had before, but I ported it to the serverless world just to get some real hands-on pain. Okay? So the first thing I want to do is I'm going to record, or what I want to do is be able to get the weather for any Go North America event. So I have a bunch of locations, right? So we have Denver, we have GopherCon, Florida, GoLang, Go Northwest, GopherPalooza. Anyone been to GopherPalooza? It's new. So that's no. OK? So we have all these. So what I want to do is be able to easily ask for an event and give me the current temperature for that event, because it may change my travel plans. So the first thing I want to do is start with the database. So here's the first couple of gotchas. Number one, most of the serverless platforms assume you're using a serverless-friendly database. And what do I mean by serverless-friendly? If you get 1,000 concurrent requests, more than likely, there's a chance you're going to have 1,000 function invocations, one each, to handle that request. If you're using a traditional database like Postgres, you could end up with a thundering herd situation and exhaust all your database connections because you may not understand what the default database pool settings are. And you also need things like username and passwords, TLS certificates. None of that stuff goes away if you're using this traditional database. So we need to think about the code that we need to write here. So what I'm going to do is I'm going to start by populating at least the table, get the data structure there. And again, what we want to do is be able to get all of this data so that way we can store the temperature, the current temperature for these things. So I'm going to switch over to the weather folder. And then we're going to go into our weather data collector. So the goal is, if I get an event name and its city, I will go out to the weather.gov and ask it for the current temperature. And then I'm going to store it in my database for faster access. OK? So this is weather.gov. So the first thing I want to do is start with connecting to my database. So I just have this in an environment variable. And then what I'm going to do now is just going to create my schema. So again, all this stuff you still need to do. And then we're just going to take a look to make sure that everything is set up correctly. No, I do not want to install stuff. And then what we'll do is, all right, we see we have nothing in the database. So the next thing I want to do is to deploy my weather function itself. So I have a series of pre-deployed functions. And let's take a peek at those. So the first thing we want to do is build a function to collect this data. Again, I'm not going to be able to poll for anything. So what I want to do here is listen to a queue for events to show up inside of the queue. So here's my weather data function, and it has all of its dependencies bundled. But here's the problem. Weather.gov does not emit events. So if I want to keep the serverless pattern clean, I need to manufacture those events myself. So we're just going to treat this as a black box for now. This function is deployed. And the first thing we want to do here is, oh, I'm going to show you some bad stuff. Now, there's no function main. But I need to go and get username and passwords. I have to do some initialization, but once. Now, don't judge me when you see this stuff, OK? All right, so here's some code. This is a function now. And we have some logging. We have a few things. And then here's my Postgres driver that I'm using. And I'm also going to be talking to the Google Maps API so I can trade the city names for actual geo-coordinates so I can send them to my weather service. Now, here's some types. You'll notice this pattern here. I need to be able to test this stuff locally. So I want to make sure that what I set up locally isn't connecting to a bunch of cloud resources, and I can just have a standing configuration function that will set up the local stuff for me. It could be an emulator, or it could just be things that are just already on disk locally. So I have this what I call a config func, so I can actually trade it out at test time. The next thing I do here is all I get is a function signature. Now look at this bit of nastiness. So I'm going to lazily load my configuration the first time a request comes in. And I'm going to go and grab all of my certificates to connect securely to the database, username and password, set up tracing, set up logging. But I only want to do it once. So here's the contract. I will be guaranteed that this function only be called once per request. This is how most serverless platforms dealing with functions work. But there's no guarantee that I will be torn down in between every request, right? So that means you can actually use global variables. You're probably using global variables anyway, but this is probably a little bit safer context to use the global variables, okay? So down here, I'm going to zoom down to the config func, and it gets a little bit more nasty. Just ignore stuff, okay? So there's a bit of setup work here that I'm doing. Now, most of these serverless platforms will do some tracing for you, right? Like send you how long did the HTTP server come in on the edge and talk to your function. But the thing is, if you want detailed traces, you're going to have to import the tracing libraries yourself and instrument every function as you go, right? You can't do that completely from black box. And I'm also going to use some structured logging. And then here, I'm connecting to a bucket where I'm storing my TLS certificate and my password, right? Because it's encrypted at rest and it's encrypted at transport. And when my function starts, it starts with an identity that allows me to get these things. All right, then we're going to zoom past some of this stuff really quickly. We set up our connection driver, but here's another important piece you have to recognize. By default, you need to make sure that your database connection pool doesn't have more than one database connection per function call. If you don't, you can imagine 1,000 functions coming up, and each of them having 3 or 4 idle connections. You're going to exhaust your database connections. Now, the solution to this could be use a different database. But look, sometimes you have what you have. But this is something you really need to pay attention to. This is the thing that bites people when they go into this world for the first time. All right, so let's go move on. So remember, we don't have events. So we need to manufacture some events. I'm going to show you what an event payload looks like. So we'll look at the one for GopherCon. So basically, I want an event that tells me the event name and the location so that my function can spin off and do its thing, right? The weather service doesn't have these, so I'm going to have to do something myself. So to ease things, I'm just going to use a cron job or a schedule job in the back end. So here's a schedule job. I'm just going to show you this little script that I have. So I want to create one for each of these cities. So basically, I'm just going to say, hey, run this event, and what it should do is land in the message queue, and then the scaling of my function will be handled by the cloud provider, and every 5 minutes, this will kick off. So let's start this. Bash bin create schedule jobs. All right, so it's running, and we should get one of these in place for each of these. So now that we kind of have this pattern, we're going to zoom through and build the rest of this application, kind of using this serverless pattern. The next thing I want to do is check the database to see if anything shows up. Okay, so we'll do source, pgenv, psql. All right, so we don't see anything yet because I need to actually trigger these. So they're scheduled to run every 5 minutes. So let's speed things up a bit, and we're just going to run them now. So they haven't run yet, so we'll say run now, run now, run now, and guess what? Run now, and run now. All right, and these will then run on a schedule. So if everything is working, they should end up in the queue, and the provider handles the scaling for me. So let's look here and see what we get. All right, so we have the current temperatures for each of these. If you live in Virginia, it's hot as hell. So now that we have all this data, what the hell happened? So I'm using a library called OpenCensus. So this allows me to instrument even my functions so I can actually deal with some of the complexities of this black box. So let's look at some of the tracing data we got from those set of calls. So we come over here to our tracing data, and then I'm going to go look at this weather function that got called. So here it is. And we can see that it ran for about 1.7 seconds. And we can see that maybe we had a cold start from the first invocation. We called the maps API. Then we called the places API. And then we called the details to get the coordinates. And then we call out to the weather service, which then eventually goes and gets stored in Cloud SQL. Okay? So this is how you start to deal with being in that black box. Without the tracing, you will be flying blind, and this stuff is almost impossible to debug. So let's move a bit faster. The next thing we need now is an API service. So I have a function, again, dedicated to just being my API. A lot of these tools come with the ready-to-use TLS certificate and so forth. So we'll just grab this, and then we'll just go curl against this API. All right, so we'll just do this. So we'll say curl. There we go. So we'll do for GopherCon. And great. We see our function is coming up. And you notice that the cold starts aren't that bad. They range in between milliseconds up to maybe a couple of seconds. So you need to think about that if you have something that's user-facing. But usually, once you invocate one of these things, every other request is pretty fast. Okay? So that's a simple API, and again, it only handles one thing. One function returns data. If I wanted to use this API to add data, that would be another function, okay? So you need some API gateway to glue this together. The last thing we want to do now is, or the next thing we want to do is have a front end. So I have a front end deployed. Let's scale this down. So what we want to do now is breeze through this. So let's look at, where was it hot as hell again? Capital Go. All right, and there we go. So we see that we get our weather information here, and again, we have traces for all of these endpoints. Now, we're going to wrap it up here. Here's the thing. Once you have this pattern, it's much easier to just build new functionality. So people say, hey, if I'm in an enterprise and we have a bunch of monolithic stuff, we're not going to port all of this stuff to a serverless platform. How do I embrace some of this technology? What should I do? Well, if you have existing services, think about net new things. When mobile came out, a lot of people got a few net new services. You got a decision to make. You can add it to your monolith, or you can build something new. In this case, these days, if you don't have voice integration to your app, you're just not up to date, right? Web UIs and APIs, that's so 2017. So we want to go into modern times. So I'm going to use another thing. And again, remember, I'm not running any of these services. All of this stuff is kind of managed platform, so I can kind of focus on the business logic. So there's a tool called Dialogflow, and I want to be able to ask my service what the temperature is for a given conference. So a few things I got to do. I have to specify my intents. Most of these hosted things, you give it a bunch of expressions. It turns those into parameters. It does some ML in the browser to, there's no way you're going to put every phrase that someone would ask in here. So you just give it enough training data, and it does the rest for you. Once you have that, I resolve this into a set of entities just to make sure that the spelling goes correctly to the backends. And then you wire it up to some other endpoint. So you have to have a fulfillment endpoint. And again, most of these serverless platforms will just give you some HTTP URL, HTTPS. Your API gateway can do authentication. So you should be all set up at this point. And again, this probably took me about 15 to 20 minutes to write, mainly because I didn't have to deal with any boilerplate, just a handler. I'm going to show you the code before we run it. So this little weather assistant here, now that I have my little pattern in place, the only thing I really need to think about here is I do want my traces, so I grab to make sure that I can trace data throughout the stack. I'm using structured logging so I can get a little bit more semantics. And all I need to do at this point is handle the webhook request and return. Okay? That's all I need to think about in this particular code. So prototyping these things become pretty easy. And then a lot of times, depending on your platform, the thing you prototype ends up being very close to what you would probably use in production. Now, let's test this out. So I'm going to use this emulator. So let's try this out. So we have this wired up into that function. And let's go. Let's see it.
OK, let's get the test version of weather function.
Hello, Kelsey.
Ooh. Hello.
Looks like you have a pretty large crowd here. I hope the demo gods are on your side.
Not a lot of confidence. So what we want to do is say, what's the temperature for GopherCon? That's where we are. Okay.
The current temperature in Denver, Colorado, USA is 70 degrees Fahrenheit.
Seems to work.
Okay, I gotta admit, that was pretty dope.
So with that's the end of the presentation. This serverless thing I think is real. It's pushing the boundaries of UI. And I think if people really embrace this, we might be able to build things a lot faster and reduce the boilerplate. Thank you.